operation time of workstations, one thing. The second one, to avoid the blockage of station and blockage of station and starving of station. Blocking of station and starving of station. To avoid this, what happens? Or some of the workstations have come for the maintenance in between. That particular time, the part which is required for the other machines can be given by a stored buffer stockage. The meaning of the storage buffer is that in between the two workstations, a particular type of automated storage system will be provided that will be storing the extra parts which will be required frequently by the next machine when the previous machine has come for the maintenance, or if cycle time is minimum or maximum. Due to variation in the cycle time also, sometimes some of the products have to be stored, so that storing can be done by the storage buffer. The storage buffer is not a manual method, not simply dumping all the material by manually. It is not. It is automatically the extra material will be loaded into the storage buffer, and whenever it is required, automatically the stored material will be retrieved from the storage buffer and it will be put into the conveyor automatically by means of automated device. So this is what is called as a storage buffer. And what are the why we are going to have the storage buffer? The basic reasons are to reduce the impact of workstation breakdown. As just now I told, if there is a breakdown in the workstations, so due to this, what happens? The next machine will be suffering due to the lack of materials. So that time the storage buffer will be providing automatically. And the next one is to provide a bank of parts to supply the line. So that means automatically in the manufacturing systems, this particular parts will be supplied automatically. The next point, to provide a place to put the output of the line. Okay, so it is out of our discussion now, to provide a place to put out of line. Okay, and to allow for curing time or other processing delay. Okay, curing time and other processing delay. So here a design is made to provide a sufficient time curing to occur before supply of the part to the next station. So not only to provide or to satisfy the starving of station and blocking of station while the material is moving from one station to the other station. For example, I have done welding in one station. So suddenly, if I have to get to the next station, some amount of curing time have to be given so that it will be cooled down, or some painting has been done, or galvanizing has been done on one part. So some amount of curing if you have been given. So while it is going to the next station, what happens? The paint will be disturbed. So during this case, what happens? Simply it will be letting into the storage buffer, and again it will be taken to the downstream and it will be taken to the upstream. That means onto the conveyor automatically. So by the time it is taking the rotation, some amount of time will be consumed so that it will become a curing time. Okay. So to reduce the impact of workstation, to provide a bank of part for supply of line and allow the curing time or the other processing times. The next one, smooth cycle time variations. So smooth cycle time variation, as I told you, all the workstations need not to have same working cycle. There will be variation in the working cycle. So to compensate this variation in the working cycle, to balance the line, these buffer storage units will be used. So kindly note down this buffer storage. It is short. Write a short notes on buffer storage, and write the reasons for having the buffer storage. These are the reasons. Okay, and control of production lines. Control of production lines. See, the workstations are there. N number of workstations with the raw material input, with the finished product output. In between them, we'll be providing some kind of conveyors, or a chain conveyors, or a belt conveyors, or leather conveyors, or some other roller conveyors. so many other conveyors will be used, and these will be attached with some of the work part holding devices, and these work part holding devices will be attached on these conveyors, and these will be conveying the part from one station to the other station. And along with this, there will be some kind of uppenders and downenders. These will be orienting and reorienting the parts onto the line, onto the machines. Necessarily, they are going for the assembly or some kind of processing. And another one, there will be some kind of electrical and electronic devices. The electrical device may be a stepper motor. It will be the stepper motor will be for one pulse, it will be rotating by some advanced by some other by some rotations. That means for each rotation, the distance of movement of the conveyor will be limited, or it will be constant. So all these will be integrated together, some kind of computers devices, and these computer devices will be having some kind of programs like PLC, programmable logical controllers. These programmable logical controllers will be controlling the specific activity of particular station, and it will be integrating one station with the other station. Okay, and all these complicated system will be controlled by a single panel. In such cases, a controlling system of production line plays vital role. And basic function of this control of production line is control the functions and controllers. There are two important operations: control functions and controllers. Okay, and what are these control functions? There are three basic control functions will be used often in the industries. One is a sequential control, safety monitoring, and quality control. Okay, the control of production line, the control method which is adapted to control the production of the systems, and here the control the production or a processing of the material will happens at each and every location or at each and every workstations. These workstations will be integrated by means of different conveyors, and on these conveyors there will be different work part holding attachments will be there, and there will be number of sensors will be provided in between these. So sensor will be sensing the presence and absence of the object for the next sequence of operation, and all these will be controlled by a specific control panel, and this control panel configurations programs can be changed by means of a computer by looking into the monitor, by just like the computer-aided manufacturing softwares, computer-aided design software, so many other softwares will be used, and by this we are going to change the machine configurations. There are two important control functions. One is the control function and the controllers. These are two important things which frequently, oftenly we are going to use them. And control functions are three: sequential control, safety monitoring, and quality control. And what are these purposes? We'll try to see them. Purpose of sequential control. As the name indicates, the sequence of operations, sequential control. So what happens, what operation to be done first, what operation to be done next at different workstations sequentially, these will be controlled by sequential control systems. The sequential control system, just like in case of our welding machines, welding systems, there are three, or for example, there are three welding robots. These sequentially, the three welding robots will be performing their specific functions once the object is coming to them, and this sequential control will be done by using sequential control systems, sequence of operations. Okay, and it includes both logical control and sequential control will be included into this. And safety monitoring, the one important thing is that the safety, the main purpose of going for the automation is not to get only a maximum output. At the same time, we have to provide a safety to the human workers, along with safety to the work part and safety to the systems and whole configured systems, integrated system. So this safety monitoring devices will be often provided within the work line and at a specific location of the work line. For example, you take a robot will be controlled, will be having three safety monitoring systems, three main safety monitoring system. Robot on the robot, there will be sensors around the working station, that is work volume of the robot, there will be sensor, and after the work volume of the robot there will be sensor. So these sensors, the tertiary level of sensor, secondary level of sensor, and primary level of sensor. The primary level of sensors will be used to safeguard the workstations. The secondary level of works, the safety monitoring systems will be used for the suddenly within the work volume of the robot. For example, within the work volume, working space of the workstation, human intervention happen. So that time the work has to stop. The whole the working have to be stopped so that it will safeguard. That is the secondary safety monitoring system. The tertiary monitoring system is that any before it enter into the danger, any human intervention or part is entering, that means the signal will be processed. The signal will be sent to the systems. That is to say or to make a safety, it will be giving you the alarm or it will be giving you the red light, so that some intervention will be going to happen. Okay, so there are three the levels of safety monitoring will be provided for workstations or the robots: the primary level, secondary level, and tertiary level. The primary level is safeguarding the workstation or a robot itself. The secondary level is that within the work volume of the robot or work volume of the workstation. What is the meaning of work volume? For example, the assembly operation is happening. The assembly operation will be happening within a specified work volume or work area. Okay, that is a secondary level of monitoring system will be provided. Within this, what happens automatically, some of the devices or robot arm or the workstations, the operations will be carrying out, and suddenly human intervention, some unwanted object is entering into the secondary level. So that time suddenly the operation will be stopped. That is the secondary monitoring system. The tertiary monitoring system is that just like a sensor pad will be provided around the work volume, a pad will be provided just like welcome pad in front of your house. These will be carrying the sensors. Once any human intervention or some object is entering, these pads will be sensing the presence of the object, and which will be sending by means of a feedback and some kind of still it is not in the danger situation, because the intervention is going to happen, red light or alarm will be switched on. So that means to say some object is entering into the system. So that is the safety monitoring devices will be provided on all the workstations or the automated devices to avoid the hazardous operations or to maintain the safety. The next one is the quality control function. The quality control function. Hello.
System volume something.
Pardon, tell me.
Sir, system volume ಅಂತ ಹೇಳಿದ್ರಲ್ಲ ಸರ್. ಅದಂದ್ರೆ ವರ್ಕ್ ಸ್ಪೇಸ್ ಸರ್ ಹೇಳಿದ್ದು ನೀವು.
Not system, the work volume or work area. For example, you are sitting in the examination, okay, on a table you are going to keep your papers and all, and you will be given some certain specified area only. Within this you have to act. You should not cross this. That is your work volume. Okay, like this, a particular machine is there which will be having some arms and work holding devices, so many things. Or a robot is there, robot will be having its arm that will be picking the object and keeping somewhere else. So which will be working within a specified area only. That specified area is called workspace or work volume.
Okay, sir.
Okay, thank you. And within this only, for example, I will be giving a very simple relative example. And you are sitting in the examination. Please don't take it as example. You take the robot as example. And on you only some kind of a safety monitoring the sensors will be provided that will be safeguarding you. And another one, any chit or something is falling within your work volume, work area. So that will be sensor which will be sensing, that will be secondary level. Okay, suddenly you will become alert. You will become alert. Some chit are simply thrown by someone else within your work volume. Okay, and another one, the tertiary level is away from your work volume. Some kind of pressure pads will be provided. Human intervention or work part is falling onto this. The sensor will identify and send the feedback to the systems. So that is will be tertiary level. At different levels, the sensors will be provided only to safeguard the machine, safeguard the human being, and safeguard the work part. Okay, these are the second the safety monitoring devices. The third one is quality control functions. Quality control functions, yes, the name indicates the quality control. Quality of the work part how to be controlled, and in between the work part, some quality control system or measuring systems will be provided. And in case of a CNC machine, the control system or quality inspection system will be well built within the system itself. It is online inspection method. Online inbuilt inspection method, therein the rejections will be zero. In some other cases, the quality control is very, very important thing. You can see that the quality of the product, that means any rejections happen, the quality is out of order, those have to be rejected from the line, so that unnecessarily working time can be reduced while it is going to the next work session. So all these will be provided only to have to achieve a quality product output. Okay, so many times these control of production line, this has been given as a short notes. Okay, for 10 marks they'll be giving you what is explain the quality production line. Okay, so there are control functions and controllers. The control functions are three: sequential control, which will monitor the sequence of operations, what work to be done first, what work to be done next, what the work to be done next, like that. The sequential operations will be controlled by a sequential control. And safety monitoring, the monitoring the safety of the systems, the safety of the workers, safety of the machine or a mechanism itself, and safety of the workers and the work part. All these will be taken care by the safety monitoring systems. And another one, the high rejections can be reduced, or the rejected part, it should not be sent to the next workstation, and the work part will be inspected within the system itself. All these care will be taken by quality controls functions. Okay, quality control functions will be taking control. And the controllers, on the automated lines, this I will be discussing in the next class. And I think the next class will be completing this particular the chapter. Only I need to discuss about the please let me have a discussion about this one. Automated production system I have discussed, automated manufacturing systems I have discussed, the types of automation, fixed automation, flexible and computer like automation I have discussed, reason for automating I have discussed, computer integrated manufacturing, that is SIM, CAD, CAM and SIM I have discussed. Okay, and what are their elementaries I have discussed, and mathematical model and matrices, that means the production rate, production quality, utilization, availability, manufacturing lead time, work in process, WIP, and some of the numerical problems I have discussed. And automated production line and assembly systems, under this I have discussed what are the fundamentals and system configuration and applications, automated flow lines, buffer storage, control of production lines. Okay, these I have discussed. Next class I'll be discussing some of the remaining important parts, and after this we'll go to the CAD and computer graphics softwares, or we'll go to the next the third unit, that is the robot technology we'll discuss. Okay, anything else you want to discuss in this?
No, sir.
Okay, this up to the previous class I have not sent the PPT